Alright, welcome to the video for 3.2. We're going to talk about compound statements and connectives, right? So we're going to put two statements together with some type of connective. We have three objectives for today. The first one is to express compound statements in symbolic form. So we're going to translate the English to the P's and Q's and figure out what the symbols are for and, or, if then, and if and only if. We're going to express the symbolic statements with parentheses in English. So we're going to introduce a type of order of operations. And so 3, that's actually the use of the dominance of connectives, which is very similar to the orders of operation in algebra. Okay? So when you have a simple statement, simple statements convey one idea with no connecting words. Alright? London is the capital of England. Paris is the capital of France. Compound statements combine two or more simple statements using connectives. London is the capital of England, and there's the connecting word. Paris is the capital of France. Oops. Connectives are words used to join simple statements, like the and that I just used, or if then and if and only if. The if and only if tends to be pretty much a mathematical term. I don't know that you see that very much outside of mathematics, but it is a very important logical statement. Okay? So, and statements. If P and Q are two simple statements, then the compound statement P and Q is symbolized by P, and that little caret thing, it almost looks like the exponent symbol, right, on the keyboard, Q, and that's read just like P and Q. So this gets read, alright, just like this. And the compound statement formed by the conjunction with the statements with word and is called a conjunction. So the symbol for and is that guy right there. Alright, and that makes us happy. So here we go. Excuse me. Now let's try this, right? Example 1, translating from English to symbolic form. I have a P, it is after 5 p.m. I have a Q, they are working. Those are both simple statements, they convey one idea. We're going to write a compound statement below in symbolic form. It is after 5 p.m. is my P, and there's my connective. They are working, that's my Q. B, it is after 5 p.m. Again, that's my P. There's the and, my connective. And they are not working. So they are not working is the negation of Q, and so I put tilde Q in for not working. Okay? So that's one way to express a compound statement in symbolic form, and that is with using the and. Now, if you printed out the PowerPoint slide from the class, then you have this. And I think what I'd like to do is just simply highlight the fact that and is a connective word, but also but is a connective word that uses this operator right here. Yet is also another one that uses this logical operator, and nevertheless. All three of those get to have the same symbolic translation, okay? So you just want to pay attention to the wording. Alright. Now this brings us to our next logical connective. Remember we wanted to talk about and, or, if then, and if and only if. So we're on to the or right now. And so or statements, the connective or can mean two different things. Consider the statement, I visited London or Paris. This statement can mean the exclusive definition, I visited London or Paris, right? But not both. I either went here or I went here, all right? It can also mean the inclusive, I visited London or Paris or both, right? All right. And so maybe you say, I think I only have enough time to visit London or Paris. You know, and then your friend might say, oh, well, what did you do on your trip? And it says, well, you know, I ended up going to both. And so this is a compound statement with the or. This one is the one we're going to use in the book. This is the one we use in this class. There is a little bit of a distinction between the inclusive and the exclusive in the notation and stuff, but basically we're not going to have to worry about it too much because we're just going to use the inclusive form all of the time. You can have London or Paris, or you can have London and Paris, and it's still going to be a true statement. All right? It's going to matter a little bit more. So now we need to be able to translate that symbolically, right? So here's our example with the or. Let P and Q represent the following. P is going to represent the bill receives majority approval. Q is going to be the bill becomes a law. All right? So the bill receives majority approval, or, well, the bill receives majority approval is P. The or gets translated with the upside down version of the and, okay? So that's the symbol for it. And then the Q, the bill becomes a law. So that's the Q right there. And so I just want to highlight the fact that the symbol that's sort of the flipped over version of the and means or in our logical symbolism. Okay? So here, the bill receives majority approval. Again, that's P. Or, there's our connective. Okay, right here. The bill does not become a law. Well, that's the negation of Q, so we have not Q. So P or not Q. Alright, so there, now we've done the express compound statements in symbolic form for the or. So now it's time to talk about the if-then statement. So for if-then statements, the compound statement if P then Q is symbolized by P and then the little arrow Q. Okay, and I usually read this as P then Q. Alright, so this is called a conditional statement. Q's based upon P. Q is conditional upon P happening or not happening. So because of this, the first symbol statement is called the antecedent. Alright, the antecedent. Because ante is actually comes before. So this P has to come before. So there's the antecedent. And so the following, and I'm using this very intentionally, the following symbol statement is called the consequence. Consequence. Alright? And so, of course, that makes sense, right? If Q is conditional upon P, then this is the consequence of this happening beforehand. So this happens beforehand, antecedent. Q happens afterwards and is the consequence of Q happening. And so this sort of makes us happy because it follows along fairly logically. All right, so let's take a look at an example of a translation. Okay, so here are two statements. P is a person is a father. Q is a person is a male. And so here's our if, then. So I know I'm going to need the arrow. A person is a father. That's the antecedent. So that's my P. That person is a male. A person is a male is Q. That's the consequence. And so if a person is a father, then that person is a male. Well, and that makes sense, right? If a person is not a male. So here's our if. Here's our then. And here's a negation, right? So we're actually going to have not Q, right? For a person is a male. We're going to have not male. Then, and then here's another negation, not a father. So that's going to give us not P. All right? And so if you're not a male, then you're not a father, right? Because that's the noun that we use for the male, with children. Okay, so there we go. And that makes us happy. We're getting pretty good at this translating thing. Alright, now there are a lot of different ways to structure the if-then statements. I have a slide. Woo. So there's a lot of ways to structure the if-then statements. If P then Q is probably the most common one. Alright, so this is the one we're going to see most often. The is sufficient and is necessary, those tend to be mathy ones. Okay, you'll see them sometimes. So the other ones, they're going to pop up in your homework and stuff. So just familiarize yourself with kind of the structure of some of the if-then statements. But this is the one we're going to see most often. This is the one we're going to deal with most often in real life. All right, and this one is pretty straightforward. Okay, so take a look at this slide, and then let's move on to our very last one. Okay, that we're going to use symbolic form, and then we're going to go on to our parentheses and stuff. This is the if and only if statements. A lot of times, Professor G, he's kind of a lazy mathematician. I'm going to abbreviate this with the iffy, the IFF, and so this stands for if and only if. All right? So the biconditional, a biconditional statement are conditional statements that are true if the statement is still true when the antecedent and the consequent are reversed. Okay? So if a person is a father, then that person is a male. That is true, right? If you're a father, you have to be a guy. All right? So this has the value of true. If a person is a male, then that person is a father. Well, this is not necessarily true, right? There are a lot of males running around. My son happens to be one who is not a father. Okay? And so this is not always true. And so by reversing the order of the antecedent and the consequent, right, I've gone from a true statement to a statement that is only sometimes true when they are reversed. And so this is not excuse me, a biconditional statement. It's only true one way, it's not true both. Okay? Now let's look at another example. If a person is an unmarried male, then that person is a bachelor. Well, that's true. If you're an unmarried male, then you're a bachelor. My son is a bachelor. He's not married. If a person is a bachelor, then that person is an unmarried male. Well, that's also true, right? We reserve bachelors for unmarried males only. And so that's also true. So this is actually going to be a biconditional statement. So this is a biconditional statement because it's true both ways. And hopefully this really makes sense right here. The compound statement P, if and only if Q, is symbolized by P, and the arrow goes both ways for Q. Because remember, the antecedent and the consequence get reversed, and it still has the same truth. And so it's almost as if they took the if and only if arrow and they says, well, P if Q, and Q if P. And so we're like, oh, so it goes in both directions. So the arrow points both directions. And so hopefully that makes sense, and that makes us happy. Mathematicians do try to pick notation that sort of makes sense and isn't confusing. Sometimes it doesn't always work, but in this case I think it works very nicely. So again, we have some common English translations. Here's the if and only if. You can reverse them. Q, if and only if P. So of course we can switch around the P and the Q. If P then Q, and if Q then P. This is where the bidirectional arrow comes from. It's true in both directions. This is really wordy, so hopefully we won't see that too often. P is necessary and sufficient for Q. Okay, so P is necessary and sufficient for Q. Remember, it's both. Remember, necessary and sufficient were both translations of the if-then statements. And so when you have both of them in here, you cover both directions. This one will show up quite a bit. Okay, these two right here and this one. These are the ones that actually show up. This one probably not so much because it's too wordy and mathematicians are too lazy for that. So this is another one you just want to take a look at. Make sure that you understand the language and the examples. Alright. My slides are sticking together today. I'm sorry. Okay, so I'm going to switch back. So now we know how to express compound statements in symbolic form using the and, the or, the if-then, and the if and only if, right? So we've covered this objective pretty well. And so now we want to express symbolic statements with parentheses in English. And so that is what we have with example number 6. We're going to express symbolic statements with and without parentheses. So let P and Q represent the following simple statements. P, she is wealthy. Q, she is happy. Write each of the following symbolic statements in words. Well, here's a negation, so that is not. And here is the wealthy and happy. Okay? So I'm guessing what we're going to write is that sort of in the front, it is not true that she is wealthy and happy. Alright, so there's the negation out front. It is not true, comma, that she is wealthy and happy. Well, and I probably should have wrote she is happy, right? Because that would have been the full statement, and I just shortened it up. But you can see that the P is in front of the Q and the wealthy is in front of the happy. The negation is in front of both, right? The and, the connective is in parentheses. So I really have to put the negation out front and then put the connective statement. This is very different from this one. See, this is the negation of the P, and not the negation of the Q. So this is she is not wealthy, right? And she is happy. So I negate just the P, and then I put the and then I put the statement for she is happy. Here I think it makes less sense to leave off the she is happy. Okay, plus I don't want to mess up this statement too much. Right. Now what about this one? Here the not is in front again, so we need sort of that in front wording, and so it is not true, right, that she is happy, wealthy, the P is wealthy, or she is happy. It is not true that she is wealthy or she is happy. Okay, so those are the translations of those. With the negation out front in the parentheses, you're negating the whole statement, she is wealthy and happy, or you're negating the whole statement, she is wealthy or she is happy. Without the parentheses, the negation only goes on the one statement and not the other. Okay, so the parentheses sort of puts both of these in the group, and so we have to do that out front sort of way. This is still a translation basically from left to right, which is what we used to do when we translated word problems and stuff. So hopefully this feels fairly familiar, and this makes us happy. Alright. Expressing symbolic statements in parentheses with English. Here, notice that when we translate the symbolic statement into English, the simple statements in parentheses appear on the same side of the comma. So the comma is really important here. So if you have Q and not P, then not R, you're going to group the Q and not P together so that you have if Q and not P, comma, right, then not R, to give you where the consequence is. So these are both the antecedent, and then the comma tells you that now you're going to the consequent. And here you have P and, right, not P, if not P, then not R. So the if not P, then not R have to go together. And so you have Q, comma, right, to show that these guys are going to be together, and if not P, then not R. So the comma becomes really important in its placement. So you want to look for commas to determine parentheses. Okay, look for commas in your word statements to determine those parentheses. So now we want to translate this statement. If P, Q, and R represent the following simple statements. P, a student misses a lecture. Q, a student studies. R, a student fails. Alright, so write these symbolic statements in words. So here you have Q and not P. So Q is a student studies. Right? And P, not P, a student misses lectures. A student, now it's the negation, so we're going to write does not miss lectures. And then here's our biconditional, right? So this is our if-then statement. So I'm going to tweak this just a little bit and go, if a student studies and a student does not miss lectures, and here comes the comma, right? I need a comma here to set off the rest of the statement. Then, to show the parentheses here, not are. A student does not fail. And so that would be the way of expressing this in words, in English, okay? And again, the comma is really important to determine the parentheses. Otherwise, what happens is the if-then starts to go on the student missing lectures and not failing. So we have the same guys here, right? But we have a different example. Now we have Q, a student studies. Here's our and we need to set off the parentheses, right? So there's our comma, and then of course this is a conditional statement, so I need to start with my if, not P. A student does not miss lectures, right? Alright, then, no parentheses, right? So no comma, not are, a student does not fail. Okay? So here, because this is the first part of our connective and this is in parentheses, we're going to put the comma here. And then of course we have the negations on these. So a student does not miss lectures, then a student does not fail. And the if-then statement comes from the conditional arrow right there. Okay? So those are two different examples of where we can put parentheses to sort of change the meaning of things. And go back and look, right? What did we write for the first one? A student studies and a student does not miss lectures, then a student does not fail. So studying and not missing lectures has the consequence of not failing. This is a little different. A student studies, and if the student does not miss lectures, then the student does not fail. So the student not missing lectures has the consequence of not failing, and you're going to connect that with a student studies. So it's a very, very different meaning, and it will have a very, very different truth table when we go on to our next lessons. So this leads us to, if I have parentheses, if I have ands and conditionals and stuff, what is the order? What is the order of operations or translations maybe? And they're calling that the dominance of the connectives in this section, right? So if a symbolic statement appears without parentheses, statements before and after the most dominant connective should be grouped together. Alright, so the most dominant connective gets grouped together first. That's our order of operations, okay? And so what is the order of dominance? The dominance of connectives used in symbolic logic is defined in the following order. Now, I'm not real thrilled about this order because this is the least dominant, the negation, and the biconditional is the most dominant. And so really, you want to do all of your, in here, for the dominance of connectives, the biconditionals are first, okay? The conditionals are second, the ands and ors are third, and the negations are last. It's almost as if we've got our grouping symbol, right? Exponents, multiply, divide, add, subtract from our order of operations. We're just going from least to greatest to least right here. Here they're going from least dominant to most dominant. So whichever way makes sense to you, memorize it that way, and that makes us happy. Okay? So as we look, the next table, all right, as you're looking at your PowerPoint slides, if you've got a if-then, right, a conditional, an and a negation, the conditional has the most dominance, followed by the and then lastly the negation. And so if we were going to group these together, we would put parentheses around the whole consequence. Okay, if you've got P and Q, implies not R, okay, then you're going to connect the P and Q together as the complete antecedent, okay? If you've got P, if and only if Q implies R, then the dominance of the biconditional gives you the Q and the R together. Those are going to get grouped. And then the P implies Q if and only if R, okay? So the P implies Q is going to be the antecedent here, and the consequence is only going to be R. So we've got two last ones. This one is ambiguous, this one down here. This one makes me a little sad. Okay, and the reason this makes me a little sad is because you've got the and the or, and it has ambiguous meaning. These are both on the same level of dominance, and so I don't really know what to do here. So here you would need parentheses, right? You're going to need parentheses here. Okay. I know this is a long video, but we only have 2 slides left. We just want to use a couple of symbols, right? Write each compound statement in symbolic form. If I do not fail the final course, I do not fail the final course, right? So I fail the final course is P, so this is going to be not P. If and only if, okay, so the if and only if is the biconditional. I study hard is Q, and I pass the final. I pass the final is R. The connective here is and. And if you wanted to use parentheses around this, you don't need to because of the dominance of the connectives, right? But if you wanted to, this is the most dominant, and so before and after it gets grouped together. Okay? So that's pretty straightforward. That makes us happy. Here's our last one. So I do not fail the course. I do not fail the course is not P again. If and only if, there's my biconditional. I told you it was the most common. I study hard. I study hard is Q. Now notice, there is a comma here. Remember, I told you to look for those. That comma right there means that now I have a set of parentheses with the and. I pass the final, which is the R. Okay? And so this is a very, very different sort of situation, because now the dominance of the connectives would have put the Q and the R together, just like in our last example. But because there was no comma here, but because there is a comma here, we got to change where the grouping symbol is, where the parentheses are. Alright? So this concludes 3.2. Please go on to 3.3, and I hope you've enjoyed this video.